So in this chapter, we're going to look at basic modeling tips. And what I'm going to talk about here are basic best practices and workflow tips and tricks. It's not going to be a very long chapter, but hopefully you'll take on board these suggestions and they should hopefully help you with your modeling, both in this DVD and also in future DVDs in this series. So the first tip I would give you is save your model frequently while you're working. And the reason for that is that two things can happen. You can make mistakes and also 3ds Max can crash. Like any piece of software, you will get crashes from time to time. And what you'll actually find is that if you're working on a particular modeling feature in Max, sometimes you may find that there's a bug in that particular tool. And that means that you'll get more crashes than other people who are working in your team. Well, sometimes there's no way around that, unless you actually get a bug fix from Autodesk, you're not really going to solve that problem. So the best thing to do is to work your way around it, and you can do that by saving frequently. The easiest way to save frequently is to use the save as, and you can use an increment button here to save as a new version. But if you want to use a keyboard shortcut to do that, for instance, if you want to go to save, you can do Control S. Well, there's actually a keyboard shortcut for that button, the incremental save. So if you go to Customize User Interface, and if you go down to, at the moment I'm showing all commands, we just need to go down to Save, so S, A, V, there we go. And you can see there's an option here, Save Incremental. So if we do Control S, let me just click here. I'm going to go for Control S. You can see this is already assigned to Save File. So let me try Control Shift S. And you can see that that's actually not assigned to anything. So I could actually assign that now and then save that out. It's going to save out this configuration. And now I'm going to hold down Control, Shift, and S. And when I save, if you look up here, you can see this increments every time I press Control Shift S. So that's a really quick and easy way to save out your models. If I go to save as, you can see we've got these extra versions now. Another way of saving out is to use the hold and fetch system. And these are here. Now hold and fetch is a very simple system and it's been in there since 3D Studio days. So what you can do is if you hold down, if you go to hold, that actually saves the scene very quickly. And if you go to fetch, that fetches the scene. That basically reloads it. Now, that may not seem to be particularly obvious, but so let me just do that again. Hold that, and then I'm going to convert to editable mesh, and I'm going to delete part of here, and then I've gone, oh no, what a terrible mistake. I didn't really intend to do that. So I'm going to go back up to fetch, tools, sorry, edit, fetch. Do you want to fetch? Yes, I do. And there we are. We've got our model back. So hold and fetch is a supplementary way of saving out a scene and making sure that if we make mistakes or if there's a crash, we can always go back to the state we were in when we held the scene. Alternatively, as I said, save your scene very often. And therefore, if you've got any sort of bug that creeps into your model, or if your 3ds Max crashes, or if you make a mistake, you can always go back to a previous version that may have been only saved out, say, 10 minutes ago. So you'll only lose a small amount of work in that circumstance. Along with the theme of saving out frequently, another technique that I often use is that I save out before and after I make a major change to the model. And there's a good reason for that. If you're going to make a major change to the model, let's say you're going to delete hundreds of vertices or you're going to do some kind of esoteric modification using a modifier, well, that's a good point at which something could actually cause a crash. So again, it's a good idea to save out before you do that. And then when you've carried out that operation and everything's hunky dory and your model's looking great and you're jubilant over the fact that you've improved your model so greatly with that particular modeling operation. Well, again, it's a good point to save because you've actually made an improvement to your model. So at that point, again, it's a good idea to actually save out your scene, and therefore you've got a good sort of base camp to go on from. Whilst you're modeling, you may find in some circumstances that you need to be able to see things behind another object. So in that case, the Alt-X keyboard shortcut is your friend, and that will actually make an object semi-transparent. We can't actually do it with this frame because it's got its display properties controlled by layer. But if I created some, let's say some teapots here, then I can do it with these. So I can go Alt-X, 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 and then they're transparent. And that actually, you can see through them. And that can be useful when you're in, certain modeling circumstances. So Alt-X is the toggle for that particular feature. And as we saw in the last chapters, it's very important to bevel edges when you're modeling. This gives you better highlights along those edges and can really make the big, a major difference to a model. It's the difference between, a modeler and a high quality modeler, an advanced modeler, to actually put your bevels in there. It does take time to do, but it really is important and gives an extra level of quality to the models that you output. And another thing to bear in mind is that if you're going to do any kind of deformation on a mesh using, say, a modifier, then it's always a good idea to put the right level of tessellation on that object to actually support that deformation. So as an example, if we had the cylinder here and I wanted to put, say, a bend modifier on this, let's just do that now. Just go and grab a bend. Should be up here. Where is he? Bend. And we bend it. Then you can see this doesn't look so great. You can see this, the size of the faces is such that when we bend it, we're getting noticeable tessellation there. I'll increase that, and you can see it'll look worse and worse, basically. So in that kind of circumstance, take advantage of the procedural nature of Max, go down to the cylinder, or whatever the mesh is, and increase the tessellation in the dimension that needs it. So in this case, it would be the height segments. We just increase that here. And now we've got a lovely smooth curve there, whereas before we had a nasty sort of tessellated looking surface. So again, this would hold for any kind of geometry. If you had a plane and you wanted to deform the plane, if we wanted to put, say, a bend modifier onto this plane, let's just do bend here. Actually, maybe a plane isn't the best choice. Let's use a cube instead. Let's go for box. There we go. Give it a little bit of depth. Small amount of tessellation. And now if we go down and we choose bend, put the bend angle up here, just going to modify the center a little bit. It goes down here. You can see that, we've got some pretty nasty looking bend here. So we just change this slightly. Go up here, and you can see in this case, if we increase the subdivisions in height, we can actually improve this quality here massively. So always bear that in mind when you're using any kind of deformation. Make sure that your mesh can actually support that deformation with the amount of tessellation that it has in the dimension that you're actually causing the deformation to take place in. Another optimization is that if you're using any kind of smoothing on a surface, let's say we've got a plane here, and I'll just tessellate this a little bit more, just so it supports smoothing a little bit more. And I'll convert this to edit poly, and I'll apply a turbo smooth modifier. There we go. So let's say we crank up the smoothing iterations here, and I go down here into the model. We'll just show the end result. I'll pull this face up here, pull this face down here. And that's all looking really hunky-dory. Well, maybe when we're working, well, when we render, we need to have a really high level of tessellation. So maybe we need 6 levels of tessellation, and you can see that's really quite slow to display. Well, one of the things that you can do with these modifiers is you can actually have a viewport iterations and a render time iteration. So we could say at render time, I want 0 iterations, and in the viewport I want 6. Well, that's actually kind of nonsensical. It's usually the other way around that you want it. So you could change the viewport iterations to, let's say, 0 or say 2, which gives you a rough idea of the smoothing. And then at render time, you could have 6 iterations. So if I did a render of that, at render time, you get this lovely smooth surface. Well, when you're working on a character rig, let's say, if you handed your model over to a rigger, you may not actually need to see the smoothing at all. So you might actually put this to 0. And that seems to be a pretty good optimization. But the truth of the matter is that 3ds Max is still actually evaluating this modifier, and that takes time to do and processing power. So if you're actually going to have 0 tessellations in the viewport, then why not actually turn it off in the viewport and have it only active at render time? And that means that now this stack is actually much simpler to evaluate when you're working interactively in Max, because it's just going to look at this modifier and it's going to see that it's actually turned off in the viewport, and it just ignores it. And it's very, very fast for it to do that. And when it comes to render time, it's going to see that the modifier is actually on in the render, and then it's going to perform the change that you've specified, which is that at render time it will have 6 tessellations. So that's the same with pretty much all modifiers. If you don't need to see the effect in the viewport, then why have it turned on? Just use the off in viewport feature, not off, but off in viewport, and that means it won't be visible in the interactive viewport while you're working on animation or whatever, but when it comes to render time, it will actually become active and smooth your model. And that's true of other modifiers which are very, very computationally expensive, things like flex, things along that kind of line. And when we displayed those polys in that tessellated mesh, it's not very easy to show here, but if I just turn this back on and we change the iterations to 6, let's say 7, well, it can be a little bit slow to display, and you can actually see I'm getting something of a viewport slowdown here. This isn't that easy to show because obviously I'm using some recording software, which kind of also slows down the recording process. But it is actually, for me anyway, noticeably slower now that I have that many tessellations. And the reason for that is because this object is actually an edit poly, and edit polys are actually really slow to display in 3ds Max. And that's true in both in Direct3D and also in OpenGL. So the solution to that is to hand over to the engine some kind of edit mesh instead of an edit poly. So the easiest way to do that is to go to the top of the stack and go down here and use turn to mesh, and that will actually convert the mesh to an edit mesh at that point. Now, if you orbit around, you should find that it's actually faster to display, and I'm actually finding that it is now actually faster to display, and I get a much faster interactive update. Now, let's say at render time you don't want that turn to mesh to be active. Well, that's easy enough. You can actually say off in render. So now turn to mesh is only active in the viewport, and when it comes to render time, it won't actually be active anymore. And it may actually cause artifacts, let's say with an edit poly. It shouldn't do, but it might do, and in which case you can just use that feature there. And let's just wrap up with some more tips for modeling, and we're going to focus a little bit on mesh modeling, obviously. So let me just get rid of this turbo smooth, and here we have our mesh here. Well, we mentioned earlier that you can use the keyboard keys 1, 2, 3, 4, and 5 to change the submesh types. So that's always worth bearing in mind. It's a very quick and easy way to get to a subobject level. With Edit Poly, you can press 6, and that will actually take you out of subobject mode. If we get our mesh here, I'm just going to tessellate it a bit actually by putting a turbo smooth modifier on it again. Just get that, and let's just put it up to 2, and then I'm going to convert it to an editable poly. We can actually change a selection that we have, a subobject selection, by holding down Control. So let me show you how that works. Let's say I have some polygons selected. Let me just select these here. If I hold down Control and I click on vertices, you can see it selects all of the vertices that were involved in those polygons. Let's say I hold down Control and then I click on polygons. Now it's going to select all of the polygons that were involved with those vertices, and we can go back and forth. But every time I do this, when I go back to polygons, our selection is actually going to grow because this vertex here will actually select this polygon as well. Now, if we select edges, we get the same kind of thing. We can just select edges, hold down Control, go to vertices, we get those vertices, go back to edges. As you can see, it grows. So let me just undo that a couple of times. We could go to polygons, and we get the polygons which use those edges. So it's quite an easy thing to grasp there. There is one other option, which is holding down Control and Shift. Let me just show you how that works. If I hold down Shift and Control and then click on vertices, look at the area that we have here. I'm going to click now. You can see that instead of getting all of the vertices that were involved in those polygons, we only get all of the vertices which were inside the border. So you can see we've basically gone inwards here. And then if I hold down Shift and Control and go back to here, we just get this selection. It doesn't actually grow, as you can see. So you've got the option there. You can either hold down to Control and then change your selection by doing that, or you can hold down Control and Shift, change selection in that way. And it works, they both work in the way that I've just described. Control will select anything that's involved with that object on a different layer, whereas Shift Control will only select those objects which were inside the border of that particular sub-object selection. We'll finish off with just one more little tip, and that is when you're working in Edit Poly, there's a really cool little button called Repeat Last, and it's here. So what you can do is, let's say we did a bevel, let's say, like that. Well, we could OK that, and then we might want to bevel again. Well, you could actually go in and set up those values again, or you can just hit the Repeat Last button, and it repeats what you did last. Now, there's a keyboard shortcut for that, which is colon on the keyboard. So you can use colon to do the same thing. And that will repeat any modeling action that you've carried out inside the Edit Poly. So you can OK that, and then press colon, and it'll repeat that extrusion. And we'll finish off with one thing that we actually hit on earlier, which you can almost see here. So I'll just very quickly explain it before we finish here. And that is, when you're doing a lot of modeling operations, you can act on the polygons as a group of polygons, or you can actually act on them as individuals. And this will give you quite different results. Now, one of the most obvious situations where you have that is with the extrude tool. If we click on extrude, you can see that it's actually extruded all of these faces outwards, and it's treating them as what it calls a group. So it's basically working out a normal, a surface normal for all of these polygons, and then it extrudes all of them along that normal. So that's why it calls it a group, because it's using a group normal. The second option is to use a local normal, and that means that the faces, the polygons, will actually extrude along their own local normal. That's their own normal. And you can see in this case is causing problems here. So in this case, using group normal is actually better than using local, because it actually causes the faces to start crashing into each other. And then the third option is by polygon, and that means that it not only uses each polygon's own normal, but it also allows them to split apart. So let me show you that. So now, as you can see, all the polygons can actually be extruded along their own normal, but they're also treated as individual polygons. So you get multiple extrusions, as you can see here, which is really cool. And you'll find that feature in some other tools in 3ds Max, which is why I just thought I'd quickly explain here what the difference was between those different options here.